Hello, my name is Natalie Ho, and I'm a student at SMC, and my student ID is 2401526. Today, we're going over the extra credit project, and we have 3 questions. For the first one, it asks for the polynomial function f of x equals x minus 2 squared and x plus 1 squared. List each real zero and its multiplicity. So for the zeros, you're gonna set both of these two to 0, equal to 0. So when you do that, x minus 2 squared equals 0 is gonna be x equals 2, and then x plus 1 squared equals to 0. You're gonna end up getting x minus 1. And for the multiplicity, since each factor is squared, there's going to be a multiplicity of 2 for x equals 2 and x equals negative 1. For B, it says determine whether the graph crosses or touches the x-axis of each real zero, aka the x-intercept. Since both zeros, like negative 1 and 2, are both even, you're gonna the graph is gonna end up touching the x-axis. For C, it's asking to find the x and y intercepts. We already know that x-intercept is gonna be x equals 2 and x equals negative 1, since we already solved for that. And then for the y intercepts, you're gonna plug x equals 0 into f of x. So f of 0 equals 0 minus 2 squared, and then 0 plus 1 squared equals to negative 2 squared, 1 squared, and then it's gonna end up equaling 4 times 1 equals 4. So our y-intercept is gonna be 0, 4. For D, it's asking to determine the maximum number of turning points of the graph. And so the maximum number of turning points for a polynomial is a degree of negative 1. And so since both of them are squared, you're gonna do 2 plus 2 equals 4, and then 4 minus 1, since it's a negative, the maximum turning point of it is a minus 1. You're gonna do 4 minus 1, and you're gonna end up getting 3. So that will be the maximum number of turning points on this graph. And then for E, it says determine the end behavior using the leading term test. So our leading term is x 4, and so that would go as x to infinity to f of x infinity, and x negative 1 to f of x infinity. And since it is an even degree, it's going to be a positive leading coefficient. So now it's asking us to graph f of x. And so right here for f, I just rewrote everything so we can see easily our points that we are trying to put onto our graph. So we have the x-intercept at x equals negative 1 and 2, and then our y-intercept of 0 to 0, 4, and then our end behavior, since it's positive, is going to go up, and then we have to find our 2 more points. So you're going to plug x equals 1 into f of x. So that's what I did here. F of 1 equals 1 minus 2 squared times 1 plus 1 squared minus negative 1 squared and 2 squared. And then it's going to equal to 1 times 4 equals to 4. So for another point, we're gonna have 1, 4. And then another point, we're gonna plug in x equals 0.5 into f of x. So you have f 0.5 equal to 0.5 minus 2 squared, and then 0 times 5 plus 1 squared, 0.5 plus 1 squared equal to 5.0621. And then that point is going to be 0.5 and 5.06251. And so here we have all our points together. We have a point at -1, 0, a point at 2, 0, and then 0.5 to 5.06251, and then another point at 0.04. And since it was positive, this graph is going up. So for number 2, it's asking to graph the given system of inequalities. Make sure you use a dashed or solid line. Label all points of intersection and check your answer with decimal. So for this one, and then for 2, it says graph the given system of inequalities. Make sure you use a dashed or solid line and label all points of intersection, and then check your answer with decimal. So here we have x greater than or equal to 0, y greater than or equal to 0, x plus y less than 4, and x plus 3y greater than or equal to 6. So right here, for x greater than or equal to 0, you're working in the right half of the plane. So this is going to be a solid vertical line at x equals to 0. And then you're going to be shading it to the right. For y greater than or equal to 0, since you're only considering the top half of the plane, it's going to be a solid horizontal line at y equals to 0, and you're going to be shading above and up. For 3, x plus y less than 4, it's going to be a dashed line since it's a strict inequality, which it's going to be, since you see right here, it's less than only. So for that one, it's going to be a dashed line. And you're going to be shading below. And when x equals 4, or x equals 4 when y equals 0, and then y equals 4 when x equals 0. And then for this one, you have x plus 3y greater than or equal to 6. It's going to be a solid line since it's a greater than or equal to. And then when x equals 6, when y equals 0, and then x equals 2 when x equals 0, and this is going to be shaded above. So here we have all our points. You have x equals 0 right here, and then you have y equals 0 right here, and then you have 4 to 0 right here, the dashed line, since this one was a it was a strict inequality. And then you have our 2 right here of 3, 1. And then you're going to be shading it where every single line touches it. So it's going to be this area right there. And then for our intersecting points, x plus y equals 4 equals to, and then for our intersection points, we have these two. So you're gonna set them equal to each other. X plus y equals 4, and to equal to x plus 3y equals 6. And then you use substitution, and so you end up getting x equals 4 minus y, and then you just plug 4 minus y into the equation, so you get 4 minus y times, or 4 minus y plus 3y equals to 6 to 4 plus 2y equals to 6, and you end up getting y equals to 1 and x equals to 3, which is why we have this intersection point. And then for 3, it says to find the partial fraction decomposition of x minus 18 over x times x minus 3 squared. So right here, I just rewrote the problem, and basically you just use the general form of decomposition, which is x minus 18 over x times x minus 3 squared equals to a over x plus b over x minus 3 plus c over x minus 3 squared. And then you just multiply everything by x times x minus 3 squared to eliminate the denominators. So you end up getting x minus 18 equals to a times x minus 3 squared plus bx times x minus 3 to cx. And then you want to expand everything on the right side. So you end up getting a times x minus 3 squared equals to a x squared minus 6x plus 9, and bx times x minus 3 equals to bx squared minus 3bx, and then the last one you just get cx. And then you want to combine everything. You want to combine everything, so you get x minus 18. X minus 18 equals to a plus bx squared plus negative 6a minus 3b plus c, and x plus 9a. And then the next step, you just want to match all the coefficients. So you have x squared equals to a plus b equals to 0, and x minus 6a minus 3b plus c equals 1, and a constant of 9a minus 18. And then you want to solve. So you have, you have to solve the system. So you first have 9a equals negative 18, which you end up getting negative 2. And then for the next one, you have a plus b equals 0, which you end up getting negative 2 plus b equals 0. And you end up getting b2. And for the last one, you have negative 6a minus 3b plus c equals 1. And then you basically want to, and then you get all these numbers and then put it back into the equation, and you get negative 6 times negative 2 minus 3 times 2 plus c equals 1, to 12 minus 6 plus c equals 1 to c equals negative 5. And then your final answer, you end up getting x minus 18 over x times x minus 3 squared equals to negative 2 over x plus 2 over x minus 3 minus 5 over x minus 3 squared. And here you can see the final answer. To help me with this project, I used, again, Khan Academy. Let me just go into this. And this one just provides you with a lot of different ways for the polynomial graph. This one helped with the end behavior, the multiplicity, and zeros, which is more for question 1. And then for the last one, it was solving for inequalities, so kind of like the second question. Thank you so much for watching my video, and I hope you enjoyed. Thank you.